Welcome to Chapter 6, the Chatelier's principle. Now we are going to discuss the fourth factor, that is the effect of temperature on equilibrium. Before we proceed, let's look at some terms that we need to revise again. First, endothermic. Endothermic means a process in which the system absorbs heat. Okay, so therefore we put plus heat on the reactant side. Okay, because the system absorbs heat. And another hint that how do we know it is endothermic or exothermic? Look at the enthalpy. If it's positive, means it is absorbed heat. So we put plus heat on the left hand side or at the reactant. The next one that we need to know is exothermic. Exothermic is a process in which the system loses heat or release heat. Okay, so same thing, release heat, so we put on the product side or on the right hand side. The hint given will be the enthalpy given is negative. According to the Chatelier's principle, if the temperature of a system at equilibrium increase, the system reacts as if we added a reactant. As if we added a reactant to an endothermic reaction or a product to exothermic reaction. The equilibrium shifts in the direction that consumes the excess reactant, namely heat. Okay, so the temperature will affect equilibrium position, the rate of reaction, and the value of equilibrium constant. Okay, so this one I want to highlight. Remember, only temperature will affect the equilibrium constant. Concentration, pressure, volume will have no effect on equilibrium constant. We shall proceed with the next slide to understand what does it mean by the system reacts as if we added a reactant. Now let's look at this. Okay. The disturbance is increased temperature. Okay, before we look at the disturbance, always look at the enthalpy given. Negative means it is exothermic. When it is exothermic, means heat is released. So we write down plus heat on the product side. Okay, so the disturbance is increase the temperature. So what do we need to do in order to counter the effect of the disturbance when temperature increase? Okay, so we assume just now, there's a word here, the system as if we added a reactant. Okay, so now when we increase temperature, means heat increase. Okay, equilibrium, heat increase. Okay, so when the heat increase, what do we need in order to get back to equilibrium? We need to reduce the heat. Okay, if we want to reduce the heat, so look at which side that can reduce the heat. Okay, here release heat because plus heat. Okay, then next one is the other side, the left hand side, absorb heat. Therefore, we didn't see the word plus heat here. So in order to reduce the heat, the equilibrium position will shift to the left to absorb heat. It's just like when we mentioned about concentration. Okay, if we concentration, if we increase the concentration of the product, then equilibrium will shift to the left to decrease or to reduce the concentration of product. Now, next one that is a little bit special that we didn't learn in concentration, pressure, or inert gas is because the equilibrium constant remain unchanged. But for temperature, it will affect. So the equilibrium constant will decrease if we increase the temperature. Okay, why? When we write the equilibrium constant expression, so we know that it shifts to the left. So shift to the left means product reduce. So when product reduce means that if you compare with the earlier equilibrium constant, okay, it will reduce. Okay, now next one, what happens if we decrease the temperature? Okay, so when we decrease the temperature, same thing, when we decrease the temperature going down, so if we want to go back to equilibrium, we need to add heat, okay, or increase the heat. Okay, so we shift to the right in order to release heat. So this time, ammonia form more, so the equilibrium constant will increase. Okay, before I've forgotten, every time when we want to write explanation for temperature affecting the equilibrium position, we must first identify, is it exothermic or endothermic? Now we proceed to another one. Okay. The reversible reaction, the enthalpy given is positive. So it means it's endothermic. When it's endothermic, we write plus heat on the reactant side. Okay, so now what happens is increase temperature. So when temperature increase, in order to get back to equilibrium, we need to reduce heat. Okay, so if we need to reduce heat, meaning that it need to shift to the right, because to the right, it is absorb heat. Plus heat means release heat. Okay, so the equilibrium constant will increase because when shift to the right, increase the temperature. Okay, so it will shift to the right. Okay, more or less. Okay, I think this one, okay, there's something, the answer is incorrect. Okay, so if shift to the right means that actually this one forms more. Okay, so it should decrease. Okay, now if we decrease the temperature, okay, if we decrease the temperature, so what happened is we draw again, decrease the temperature. In order to get back to equilibrium, we need to increase the heat. So which side is increase the heat? Is to the left to release heat. Okay, so means that, okay, this one is wrong, this one should be more, this one should be less. Okay, so more NH3 is formed, thus the equilibrium constant will increase. So this one is wrong, this one is decrease. Okay, endothermic, correct? This part is wrong, this one should be endothermic. Okay, now, so this is the summary, okay, for exothermic and endothermic when the disturbance is temperature increase or temperature decrease. Okay, one reminder, for this reversible reaction equation, enthalpy H is not given, meaning that the change in temperature will not affect the position of the equilibrium. Now let's try one exercise. Using the Chatelier's principle, explain how decreasing the temperature would affect the equilibrium and state the observation. Now, first check the reversible reaction equation. Enthalpy given is positive. Positive means endothermic. Endothermic means we add heat on the reactant side. Okay, so heat is absorbed. Now, next one, identify the disturbance. The disturbance is temperature decrease. Okay, so what happened is, draw again the equilibrium. Temperature decrease means reduce. So in order to get back to equilibrium, we need to add heat. Okay, so which side has more heat? Left. Okay, now so how to explain? First, this is an endothermic reaction. According to Chatellier's principle, must write down, according to Chatellier's principle, the equilibrium position will shift to the left. Okay, why does it shift to the left? Because when temperature decrease, we want to increase. So we need it to release heat. Okay, so let's look at this. So when it shifts to the left, so more N2O4 will be formed and NO2 will become less. So the observation is, originally brown gas will turn to pale yellow. Okay, or if you don't want to write brown gas turn to pale yellow, you can just write the gas will be pale yellow. Okay, so again, summary for temperature is, first must identify, is it endothermic positive or exothermic negative. If endothermic, we put plus heat at the reactant side. If it is exothermic negative, then we put plus heat at the product side. Then we see whether the temperature increase or decrease. And then we follow again to decide whether we want to add heat or reduce heat. That's all for the explanation for temperature effect on the equilibrium position.